Assalamualaikum warahmatullahi ta'ala wabarakatuh and a very good day to all of you. Hi, I am Dr. Azizul Azri Mustafa and I am a senior lecturer from the University Technology Malaysia, and I will be your trainer for this module on Introduction to Chemical Processes. And this lecture video will be the first part of a series of 4 lecture videos for this module. Okay, so there are 3 module learning outcomes that you as a participant need to achieve at the end of the module. Okay, the first one, at the end of the module, you need to have the ability to describe the overall schematic of a chemical process plant and explain the general function of each component appearing in that schematic. And number 2, so you should be able to identify different separation process techniques and provide examples for each type of the separation techniques. And the third one is the ability, you need to have the ability to elaborate the concept of each separation process and differentiate between them. Okay, so now we move on to the outline of the module, whereby I will start with the introduction and then followed by a discussion on the overall schematic of a chemical process plant. And then after that, we will discuss in more details on the components appearing in the overall schematic, where I will start with discussing the mixing, splitting, and reaction processes, followed by discussion on separation processes. And there are many different types of separation processes which we will discuss, which include distillation and flash distillation processes, evaporation and drying and desublimation processes, liquid extraction and leaching processes. We have absorption, stripping, humidifying and dehumidifying processes, yeah, and also including adsorption, crystallization and filtration separation process, and also involving screening and membrane separations. Okay, so these are some of the separation processes which we will cover in this module, and finally we will discuss on the heating and also cooling processes. Okay, so in order to start our module, so it would be good if we first go through or discuss the definition of the terms which are appearing in the module. And the first one is on process. So what is actually a process? So a process is any operation. So it can be a single operation or a series of operations by which a particular objective each is accomplished. Okay, so there might be, of course, there will be an individual operation objective. Okay, so for each operation, there must be certain objective that need to be accomplished, and of course, there is also the overall objective of the overall series of the operation. Okay, so in this module, we are talking about chemical process. So what is chemical process or chemical processes? So chemical processes are operation that involve change in the physical and chemical behavior or characteristic of the substance or mixture of the substance. Okay, so that is chemical process, which involve operation that cause a physical or chemical change in a substance or mixtures of substance. All right, so that is the definition of chemical process. Okay, so this is the reference that I refer to come up with this definition. All right, so in this module, so basically later on I will, after explaining the overall schematic of the chemical process plant, so we will go individually explaining about the each specific processes, chemical processes which are available out there in the industries. So in order to explain that, I will be using what we call as the block flow diagram. So the block flow diagram, first of all, we have this block. So this block is representing what we call as the process unit. So the process unit, it can be an equipment, it can be an actual equipment, or it can also be a defined system. Yeah, if let's say for example we have a fluid flowing inside a pipe. So let's say the pipe is long, so we need to have a certain defined area so that we can analyze the system, or we can define the process happening inside the pipe, for example. Then for that case, it can be a defined system rather than an exact equipment. And for example, if we boil water at our homes, then of course the equipment would be the kettle, right? So that is an example of an equipment. Okay, so the process unit can be either an equipment or a defined system where the process is occurring. All right. So, in order for a process to occur, of course, there must be certain inputs and that we insert in the equipment or in the defined system. Okay. So, so another component of the block flow diagram are arrows. So we have these arrows. So these arrows represent contains materials. It contains substance, right? It contains chemicals, it contains materials. So there are many words that we can define. Okay, so there are so it contains all those compounds. Okay, and the arrows can be either pointing towards the process unit, or it can be pointing out from the process unit. So these two examples of the arrows or the streams are pointing towards the process unit. So if it is pointing towards the process unit, so it is referring to the inputs. Okay, so inputs, or in other words, we also call it as feeds. So inputs or feeds are material, right, that enter the process so that the process can occur, right? Without any inputs, then the process cannot occur, right? It need to have something, and so that process to can occur. And so like I said just now, we have another arrow which are pointing outwards from the process unit. So this arrow is representing the output stream or the product. Okay, so basically output and products are a result, are results of the process which have been occurred. Okay, so it contains the material that leaves the process. Okay, so now let's discuss about the overall schematic of the chemical process plant or chemical process industry. So of course, we need to have an input. We need to have a feed. Of course, this feed can be a single component. It can be a mixture of component, or it can be, of course, we can pre-mix this feed before we feed it into this process, what we call as reaction. Okay, so normally the main process which we have in a chemical process industry is a reaction, whereby we provide an input to the reaction, and the input to a reaction process is normally what we call as reactants. So reactants will react in order to produce new compounds, okay, which we desire. Uh, Right. Okay. So reaction is a process whereby we react certain reactants, right, which we fed into the reactor, into the reaction process in order to produce desired compounds or desired products. And of course, in order to produce that desired compound, of course, when talking about reaction, we can have side reaction. We can it Besides producing the desired compound, it can also produce the unwanted compound, which are called byproduct or side product. Okay, so the output for a reaction is the desired compound. We have byproducts, we have side products, and also reactants which are not fully consumed. in the reaction process. So therefore, the outlet or the output from a reaction is a mixture of many different compounds. Okay, so in that mixture of many different compound, we have one compound or maybe two compound of which we desire, right? See, in order to obtain that desired compound, we need to fit this reaction into a separation system in order to separate our desired compound from the rest of the compound appearing in this mixture, right? So in order to separate that compound from the mixture, we need to have a separation system, and depending on the number of compounds appearing in this mixture, more than one separation techniques or process need to be included in order to really separate all the compounds, or all the compounds which are appearing in the mixture, right? It might be that the objective is not only to remove or extract the products that we want. We also want to maybe separate the byproduct or side product from the mixture, and so that maybe we can also use that, or maybe we can, in order to throw it away as a waste, or maybe we can reuse it, or maybe we can sell it. It can also might have some commercial values. Okay, and like I said just now, in this mixture we can also have some of the reactants which are not fully consumed, so we might also want to recycle back that reactant so we can optimize the usage and to reduce waste, right? So of course there are many objectives of why we need to do separation, okay, like I have mentioned just now. Okay, so the output from the separation system would be the pure components which are successfully being separated, using the many separation processes available out there. Okay, and throughout the process, in the chemical process industry or process plant, we also need to include the heat recovery and utility system, which normally includes heating process, cooling process, increase using compressor, for example, to increase pressure of gases, using pumps to increase pressure of liquids, and to transport the material from one point to another. So we need to have the heat recovery and utility system. So in this class, we will discuss about the two process of heating and cooling. Okay, and yeah, finally we will obtain the products. Product can be our desired products and byproduct, side product, and all the compounds that we want at the end. And of course, heat recovery and utility can also be used in order to make sure that the compounds or the condition of the process is at the required value. Okay, so this is basically the overall schematic of the chemical process industry. So basically we need to have a reaction, and then the output from the reaction is a mixture whereby we need to feed it into separation systems so that we can separate the compounds in the mixture to pure compounds. And of course, throughout the process, we normally need to include heat recovery and utility in order to make sure that the compounds are at the required condition of the process. So even though heat recovery and utility is shown after the separation process, it can be also included before separation, even before reaction, if heating and cooling is needed, so that the temperature and pressure is at the required process, required condition of the process to happen. Okay, all right. So another thing I would like to highlight is that of course, not all chemical process industry need to have a reaction. Say for example, maybe the sugar industry. So normally they would use extract sugar from sugarcane. So I think for that Example, maybe reaction is not needed. Okay, they just need to use separation systems in order to at the end obtain the products needed from the raw materials. Okay, so this is a general overall schematic of the chemical process industry. And here I would like to go a bit more detail on the separation system. So the characteristic, which is on the characteristic of separation process. So like I have mentioned just now, so the inputs to the separation process must be a mixture, right? So because if it is a pure compound, then we have nothing to separate, right? So the input toward the separation process must be a mixture. Okay, it must be a mixture. And of course, we would have a separation process or a device, right, whereby we apply certain mechanism on the mixture so that we can do separation. And of course, in order to make sure that separation occur, we need to have what we call as a separation agent. Okay, so this separation agent will help the compounds that we want to separate from the mixture to be separated. Okay, and then of course the output will be pure components. And like I have mentioned before, depending on the number of compound in the mixture, we may need more than one separation method in order to separate all the components appearing inside the in the mixture. And these are some examples of the separating agent, which consists of heat. Okay, we can use heat to separate compounds in a mixture. We can use solvent. We can apply pressure. We can perform pressure change. We can use gravity, for example. We can also use a mechanical force, for example. Okay. Okay, so it is the end of the first part of the lecture video. Please proceed to the second part of the lecture video. Thank you very much.